when your legs don't work like they used to before, and I can't sweep you off of your feet. Will your mouth still remember the taste of my love? Will your eyes still smile from your cheeks? And darling, I will be loving you till we're 70. And baby, my heart could still fall as hard at 23. And I'm thinking about how people fall in love in mysterious ways. Maybe just the touch of a hand, or be I fall in love with you every single day. And I just wanna tell you I am. So honey, now take me into your loving arms. Kiss me under the light of 1,000 stars. Place your head on my beating heart. I'm thinking out loud that maybe we found love right where we are. When my hair's all but gone and my memory fades, and the crowds don't remember my name, when my hands don't play the strings the same way, now I know you will still love me the same. 'Cause honey, your soul could never grow old, it's evergreen. Baby, your smile's forever in my mind and memory. Ooh. And I'm thinking about how people fall in love in mysterious ways. Maybe it's all part of a plan. Well, I'll continue making the same mistakes, hoping that you'll understand that, baby, now, woo, take me into your loving arms. Kiss me under the light of 1,000 stars. Place your head on my beating heart. I'm thinking out loud that, baby, we found love right where we are. Ooh. La 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 la. So baby, now take me into your loving arms. Kiss me under the light of 1,000 stars. Oh darling, place your head on my beating heart. I'm thinking out loud that maybe we found love right where we are. Or maybe we found love right where we are. And we found love right where we are.
Alright, Orcas, our goal for today is to figure out what an element is, and at the same time what a compound is. We want to know how they're alike, how they're similar, what makes something an element versus what makes something a compound. And at the end of today's class, you're going to be able to classify the two. You're going to be looking at a list, and you'll be able to know that which one is definitely an element and which one is definitely a compound. And I think it's easy, but I don't want you to be fooled when it comes to the past test. So you'll do a couple classifying projects, and then you'll do some assignments on USA Test Prep, and you'll wrap it all up. Alright, so today's class we're going to eventually be learning about the difference between an element and a compound. Before we do that, we're going to start with just a little bit of review so that we're ready for the past test when that comes around in a few months. So today we're going to be focusing on soil as our review. Soil is what we're going to be reviewing. So we start with the Access Prior Knowledge part of your ISN sheet. And at the top there you see this diagram right here. What I'm showing you is soil sizes. So let's see if you can remember what the largest type of soil is, and then we went down to another size, we went down to another size, and we went down to an even smaller size of soil. Now we're going to, first of course I'm sure that you remember that gravel is the biggest, and we know that gravel is larger than 2 millimeters. Gravel is larger than 2 millimeters, But then we got to this next size. What is smaller than gravel? Think about it. Gravel. Sand. Sand is going to be the next one. So grab your pencils, and in box number A, you're going to write sand. You're going to write sand in box number A. Sand is that one right there. Okay? Now, what is going to be smaller than sand? Just a little smaller. Remember, sand feels gritty. And we know that because of sandpaper's gritty. But this next one, it doesn't feel gritty anymore because it's so small it'll actually fit between your finger tips and fingerprints. So it's kind of flowery or soft feeling is how we describe it. What's that one going to be? Silt. Good job. That one's going to be silt. S-I-L-T. So we got gravel, sand, silt, and the really smallest type of soil, the smallest particles of soil, what are they going to be called? Gravel, sand, silt, and clay. Right. Clay is going to be the last one. So A is sand, B is silt, and C is clay. Great sand in South Carolina, gravel, sand, silt, clay. Gravel, sand, silt, clay. Great sand in South Carolina. Now let's move to the right side. These are going to be descriptions. These are going to be descriptions. So let's see if we can figure out which is which. First one, microscopic particles, which means small. They're flat in shape, and they give soil a plastic, moldable feeling when wet. It has a very high surface area or volume, so it's moldable. It's shapeable. You know which one of these would be moldable or shapeable, and they're extremely microscopic? What do you think the answer is going to be? I'm going to go with clay right here. Clay. C-A-L-Y. Clay is going to, because it says microscopic and moldable. And maybe you've heard about in art class when you can do a clay project where you shape and mold things, all right? Next one. Large, round, it's coarse. There is a key word. Large is a key word, which gives soil its gritty feeling. Gritty is a key word. These particles have the lowest surface area to volume ratio of all particles. So it's large, it's rough or coarse, and it's gritty. What do you think that sounds like? I'm going to go with sand for this one. S-A-N-D. Sand. Last but not least, we got the smaller round particles, but they're still visible with the eye, so they're not necessarily microscopic like clay, and they give it a flowery feeling. That's the key word, flowery. What do you think that was going to be? And the only one left, gravel, sand, silt, clay, is silt, because we're not talking about gravel.
Dolly, please report.
We're not talking about gravel. Alright, so now we're going to move on down to the bottom left-hand side of your paper. And here we have two images. The first image is of a surface water zone, so we're going to review that a little bit. And the second image is of the soil horizon. So I think this should be pretty easy for you, okay? So we're going to start with the first one on the left-hand side. And remember at the top, you have options of what you can put here. So let's start with this one right here. First one I think that's easy to pick out. First one I think is really, really easy to pick out. Let's see. What do you think would be an easy one? Well, I know that at the end of a river, a unique ecosystem forms. And I know that unique ecosystem at the end of where a river forms is going to be called a delta. So right here in this box, I'm going to go ahead and write delta, because I know that the deltas form at the end of rivers. Okay? Now, if we're talking about the underground zones, here I have a zone that is not full of water. It's got some air mixed in with it. It's got soil and air and water and worms and decomposers, but it's not saturated. So what's that zone going to be called?
That's going to be called the zone of aeration. So I'm going to put zone of aeration right there. And if that's the zone of aeration, I know that this area below that, that is full of water, is saturated with water, is going to be called the zone of saturation. So I have the zone of aeration, and I have the zone of saturation, and I have a delta forming at the end of this. Now, let's move on up the river a little bit. Let's see. So we've crossed these out. What's going to be this high ground right here that separates one drainage basin from another? The high ground in between two of them. Think about it. Divide. The answer is going to be divide. So right here for B, we're putting divide. That's a drainage basin divide. That's like the mountain peaks that separate two watersheds. All right. Let's see. Move on. What might be, this arrow right here is pointing to the top of the zone of saturation. Let's go back and see if you remember that. What's the top of the zone of saturation called? It's going to be called the water table. And remember, that's what we have to drill our wells below. If you're going to pull water out of the ground, you have to go below the water table and into this zone of saturation. If you don't go below the water table, you're just going to be in the zone of aeration where there's no water. All right? So let's move on. Now we've got a couple options. We've got two left. Runoff and erosion occurs here. Let's start with this top one. This is going to be the area upstream, up the river. If it rains a lot up here and this rain washes soil into the river and it flows downstream, what's going to be A? What would we call A? Good. A is going to be erosion occurs here. Erosion occurs here. All right? And that only leaves us with one option. That last one is just going to be called runoff. And we know that would make sense because when it rains, water runs off into to the water. So one more time, we've got erosion occurring upstream, and it's going to wash soil downstream. We've got runoff where it rains and runs off into the watershed. We've got this high ground in between that divides or separates them, which is called the divide. And then underground, we've got the zone of aeration first. Below that, we've got the zone of saturation, which is full of water. And then that last line is going to be called the water table. Now, let's move on over to this last one, which I think this is going to be super easy. Letter O. What's letter O going to be pointing to? Letter O, what's it going to be pointing to? It's the dead, decaying, organic matter. It's nutrient rich. Ready, set, go. Humus. The answer there is humus. Letter O is humus. Now, O is a part of A. A is the nutrient-rich layer. You notice that it's dark in color. There's going to be air, water, decomposers, plant roots, all kinds of stuff inside of this letter A. What's letter A going to be? Ready, set, go. Topsoil. Topsoil. That's going to be the topsoil. You're writing that answer in that box. That's the topsoil. Moving on down to letter B. B is not the topsoil. It's like the players that come off a bench in a basketball game. So they're not, it's not quite as good, it's not quite as nutrient rich, but it's a mixture layer where leachings occur at. So what's below the topsoil? Go, subsoil. The answer is subsoil. So we got humus, topsoil, subsoil, and now we're going to move on down. We've got this layer here. It's going to have partially broken up rocks. They're not big rocks, but they're broken up. What's that going to be? Ready, set, go. Parent material. That's going to be the parent material. Parent material. And then down here at the bottom, this is the big rocky layer. It's not able to be permeated. You can't, water will not flow through it. That's what causes the zone of saturation. So this big rocky layer is going to be called the what? 1, 2, 3, bedrock. Good, you knew that one. Bedrock is easy. All right, so tying it all together, we got humus inside of the topsoil. That's the organic living stuff, or stuff that was once living but is now dead. Topsoil decomposes, breaking down that humus, and it's nutrient rich because they return nutrients to the soil. We got the subsoil, which is a mixture layer, the parent material where the rocks are being broken up, and the bedrock where it's still big rocky boulders. Now don't forget, the bedrock is weathered to produce the topsoil. So it all kind of fits together. Are you with me? All right, let's move on. Alright, moving on to the next section. We're going to get into the new information. So you're moving on down to this section of your sheet. We got a little bit of notes to do today. And what we're going to be focusing on, as I said before, is elements and compounds. And what are the difference between elements and compounds? So in your notes you see number one. Number one, this is from yesterday. So let's see what you can remember from yesterday. It says, recall that everything that has mass, you see go down in your notes, has mass, volume, and can be sensed is blank. Everything that has mass, volume, and can be sensed is blank. Matter is made of blank. Can anybody remember what that is? Anything that has mass, volume, can be sensed is known as, next slide. The answer is going to be matter. Anything that has mass and volume and can be sensed is known as matter. Alright? And matter is made of atoms. That's what we learned all about yesterday, is matter is made of atoms. Atoms make up everything in the universe. Your skin, your hair, your clothes, the table, your pencil in your hand, the paper in front of you, everything is made of atoms, all right? And anything that has mass and volume has space. 5 more seconds to write that down. 5, 4, 3, 2, and 1. Now, what is this tool called again? This is called a triple beam balance, and it's used to measure mass. Okay, we said that yesterday. And these things down here are called what? These are called graduated cylinders, and they're used to measure volume. All right, good job. That's what we learned about yesterday. Moving on. Now we're on point number 2, our new information. Point number 2, elements. Elements are blank. Elements are pure substances that cannot be changed into something more simple. Only a few words to write that down. So pure, that means they're not made out of anything else. Here I have a picture of gold. Gold is a pure substance. It's not made of anything else besides gold elements. Carbon is another example. It's only made out of carbon elements. My ring is made out of titanium. It's only made out of titanium elements. Oxygen. It's only oxygen elements. So they're pure substances. Okay? And you cannot change a pure substance. If I cut gold in half, I still have gold. If I melt gold, I just have liquid gold. If I set gold on fire, it's still going to be gold. I can't change gold into any other pure substance. It is what it is, all right? It's as simple as it gets. So keywords here, pure substance, you cannot change it, and it's simple. Here I have another picture of gold. What would you call this diagram here? Good, this diagram is going to be called an atom. Now what does the P stand for? Protons, and they have a positive charge. Neutrons have a neutral charge. And here I have a negative sign. All kinds of negative signs are on the outside. What are those going to be? Those are going to be electrons. So protons, neutrons, and electrons outside. All right, we're moving on to letter A. Letter A. Now at the bottom of our paper, it says elements are composed of blank. Elements are composed of only one kind of atom, and I know that space is a little small, but I appreciate you being patient with me. Elements are composed of only one kind of atom. So you have 5 seconds to write that down. So here I have an oxygen atom, or an oxygen molecule. Oxygen isn't composed of anything else besides oxygen, okay? What you breathe in, If you were to breathe in pure oxygen, it's not composed of anything else but oxygen. That's all this point is saying. So all we need to know here is that elements are as simple as it gets, and they're not composed of any other type of pure substance or any other type of element. It's just oxygen. Okay? Now, in reality, this is a picture of our what system again, by the way? Breathe in and out, exchange gases. This is going to be the respiratory system. When we breathe in, we don't only breathe in oxygen. We breathe in other things out of the atmosphere too. We sometimes breathe in a little CO2. But the only thing that we need when we breathe in is pure oxygen. Moving on to point number 1 at the very bottom of your paper. It says blank elements are formed of only blank. Sodium elements are formed only of sodium atoms. Sodium elements are formed only of sodium atoms. 5 seconds to get that. Alright guys, we've learned about sodium, if you can remember before. Sodium, we saw that when we talked about something in the marsh and it's something in water. Sodium chloride, and that's going to be salt. So NaCl, this can bond to form NaCl, and that's salt. But if we're talking about just sodium, just the Na part, it's only going to have sodium atoms. It's not going to have chlorine atoms making up sodium. Elements are pure and simple. They're only made of one thing. Here I have what pure sodium looks like. Even though it kind of looks like a salt, that's not. That's pure sodium. Its chemical symbol is Na. What's its chemical symbol? Na. All right. And here I have something else. What will we call this thing here? This is a diagram showing a sodium atom. Good job. All right. That's our example. Moving on now. Flip over to the back side of your notes, guys. We're halfway done. Keep rolling. All right. Now, this is just a preview a little bit so you'll know a lot more when we get later in the lesson, later in the year. The chemical symbols or letters, what do we use to make a chemical symbol? Use a letter, O for oxygen, Na for sodium. Chemical symbols are used to represent the blank, used to represent the atoms of elements. 5 seconds to get that. All right, guys, so here I have an O. What does O stand for? O stands for oxygen, okay? Here I have Na. We just discussed this one. What does Na stand for? Good. Na stands for sodium. Here I have a Cl. We know that Cl stands for chlorine. And here I have an H. This is the easiest one. We got to know what H stands for. H stands for hydrogen. All right? So these are chemical symbols, and all they essentially are is just a letter. It's like if I were to abbreviate my name, I might put SRP, SRP. That would be like a symbol for my name. Does that make sense? We don't have to always say the whole carbon. We could just use the letter C. So it's kind of like scientist shorthand. So they don't have to write the whole name out. They just kind of abbreviate it. So I want you to become familiar with these two. We use these symbols so you don't have to write the whole word. All right? We use these symbols. Oxygen, O, Na, sodium, Cl, chlorine, H, hydrogen. Rolling on, guys. Rolling on. You're doing great. Now, example. Number 1. It says NaCl. We just talked about this one, so you know it. NaCl is composed of blank. So sodium. And the chemical symbol for sodium is what? Na. And blank. Chlorine. The chemical symbol for that is Cl. 5 seconds to get that. Alright, so chemical symbols are used to represent elements, and one example of a chemical symbol is Na, which is sodium. There's a sodium atom. Alright? Another example is Cl. Here's this chlorine atom. Instead of writing out the whole word chlorine, you just put a Cl. It's short and sweet. It works. Now, when these two combine together, we get NaCl, and we know that NaCl is something that tastes nice. What is it? Salt, alright? But we also know that it doesn't taste nice if you go swimming in the ocean. You get that salt water in your mouth, it doesn't taste so good. So, symbols are used to represent elements. Alright, guys? Alright, let's roll on. Okay, now, number 2 on our paper, on the back side. Each blank has a different blank. Each element has a different symbol or abbreviation. That's a long word. Each element has a different symbol or abbreviation. 10 seconds to get that. 5. You don't need 10. 5. 4, 3, 2, and 1. All right, so all this slide is essentially saying is that you're not going to use the same symbol for a different element. It's like Na is always going to mean sodium. Na never means nitrogen. Na never means potassium. Na never means anything but sodium. Na is always going to be with sodium. Another example, Cl always stands for chlorine. It doesn't stand for carbon. Another example, H always stands for hydrogen. All right, this is just so that stuff doesn't get confusing. They made a periodic table and they always made certain letters stand for certain elements. Are you with me? It's kind of like, I don't know, it's just like your abbreviation always stands for your name. We're not going to use it for anyone else. This is just you by yourself. All right, so this is just sodium, this is just chlorine. I don't think that's too difficult to get. I think you got that. Let's move on to 2A. Sometimes elements have more than one letter. More than one letter. And you don't have to write down the example. But you can kind of see this here. Sodium isn't just represented with an N, it's represented with more than one letter, an Na. If it was just an N, it would no longer be sodium, it would be nitrogen. So sometimes they use more than one letter just so that we can differentiate between some of them, so we can distinguish between some of them, so we don't get confused, all right? So N is nitrogen, but Na is sodium. So sometimes they'll use more than one letter. And actually, some of the most recent elements that they discovered, they actually use 3 letters on it. So you could be the scientist that discovers one of those. You might put your own little abbreviation like SRP. You can name it after your favorite science teacher. Or not, but whatever. You can put your own initials. But sometimes they'll even use 2 or 3. All right, now the first letter in the chemical symbol is always going to be capitalized. You always capitalize it. So, number 3 says the blank, the first letter in a chemical symbol is always blank. You don't have to write too much here. First letter is always capitalized. So, Na, you always have to capitalize the N in sodium. You always make that capitalized. If you capitalized N, capital A something, that would be something different, okay? So you got to make sure that when you're doing these elements, you always only capitalize the first letter, all right? And that helps us figure it out too when we're looking at a molecule that's got a bunch of elements pushed together, like NaCl. We know that this is 1 because it's got a capital letter, and we know that this is another element because it's got a capital letter. Does that make sense? All right. Another example of this would be like carbon monoxide. This is C1O1. Carbon monoxide is this deadly gas. It's really, really dangerous. But we know that this is capitalized, so that's going to be the carbon. We know that the O is capitalized. And what's O stand for? Yep, you knew it. It's oxygen. O is going to be oxygen, all right? So we always capitalize the first letter. Make sure you do that. Make sure you do that. Pay attention to that. Pay attention to the details. All right, guys, good news. We're moving on into the very last section, but first I want to answer a few questions. Let's see what you picked up on today. First question. Matter must have blank. This is an old review question. 5, 4, 3, 2, 1. Good job. Matter must have mass and volume. All matter has mass and volume. Moving on to the next one. Elements can actually be reduced into simpler substances. True or false? Think about from yesterday. 5, 4, 3, 2, 1. The answer is going to be false. If you break an element down any smaller, it's not going to be that element anymore. You cannot change them. You can't break them down. All right? Well, moving on. If one atom of oxygen is divided in half, we split it in half, we divide it, then it will still have all the properties of the oxygen element. 5, 4, 3, 2, 1. This has got to be false. You knew the last question. It says if we split it in half, it's not going to be that atom anymore. So the same thing is true as here. Same thing true here. If you divide it in half, it's no longer got those chemical properties anymore. It's going to lose those chemical properties. Moving on. Elements are composed of several types of atoms. Several types of atoms. Come on, this is an easy one. 5, 4, 3, 2, and 1. Answer is going to be false. One element is always going to be composed of the same type of atom. Carbon is only going to have carbon atoms, making it up, nothing else. Hydrogen is only going to be made of hydrogen atoms. carbon is not going to be made of hydrogen atoms. All right? What is the chemical symbol for sodium? Let's see who's paying attention today. Chemical symbol for sodium. It's a tricky one. 5, 4, 3, 2, 1. Answer there is going to be Na, sodium. Now, even though sodium starts with an S, it was named by some Greek scientists. So apparently the Greek name for sodium was Na something. So they named it Na, all right? So sodium is Na, all right? S here is going to be something different. This is going to be sulfur. And this is something that makes the marsh stink. Have you ever smelled the marsh sometimes and it smelled terrible? That's because it was giving off sulfur. All right, sulfur is also given off in other places in the world, like volcanoes and stuff. All right, next one. Which of the following is not an example of an element? An element. Element. One simple atom. 5, 4, 3, 2, 1. Well, the only one to me that looks any different is this one. So this has got to be the answer. We know that this is water, H2O. This is going to be different because it's not made up of just one element. It's made up of multiple elements. It's going to have an oxygen combined to 2 hydrogens. Oxygen combined to 2 hydrogens. So it's actually going to have 3 atoms composing it, or 2 different types of elements. 2 different types of elements, but 3 total atoms.
After these messages, we'll be right back.
I would love for you to give me your honest opinion about our new headphones. Would you like to try them out?
Bring it. Let's go.
Try this one on. Throw them on. Check it out. Pick it up.
It's so clear.
Excellent.
Oh, I'll be jamming on the subway with these.
Do it. Nice.
At first, our volunteers are picking up nothing but good vibrations.
Love this song. Boom, 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 boom. And when you twerk, you can go boom, 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 boom.
Yeah, I can't twerk.
What they don't realize is we are controlling what they hear from behind the set. But what do you think will happen if we mix in some unsavory sounds? Offering up a selection of noises ranging from the merely obnoxious to get me the heck out of here.
The nails that were coming down, that was really weird because it was like the back of my mouth. The teeth were like... Now it's like a balloon.
Okay.
Oh, you love that one. Is it Spice Girls?
It pierced through my soul.
Oh! The styrofoam starts on my back, and it just works its way up like this. And then it comes up here, and then it's on my head. Oh, I hate it.
Yeah. Yeah, I don't like that. So it sounds like something. Sorry.
What happened?
Somebody's throwing up. When I heard the barf, I felt it in my body, like right here in my stomach. That made me nauseous.
So what's going on here? Why do we have such a physical reaction to nothing more than an unpleasant noise? How does your brain sense sound? And why does it respond so physically to some sounds, but not to others? Measured in something called hertz. Sound waves move through the air as vibrations. The higher the frequency, the more powerful the vibrations. The highly sensitive systems of your inner ear receive these sound waves and send information about them to your brain. Remarkably, many sounds trigger your amygdala, the part of your brain that controls the fight or flight response, suggesting our brains have actually evolved to associate sounds of a certain frequency with danger or distress. These sounds aren't language, but they do communicate. They are meant to trigger an immediate biological response. So those shivers you feel are probably tied to our ancient survival instinct.
Atoms. Okay, moving on. Now, last bit of notes, guys. Good news. Roman numeral number 3. Compounds are blank. Compounds are pure substances. Compounds are pure substances that are composed of 2 or more elements. that are blank, chemically combined. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right, guys, there's a lot of meat here, so let's make sure you understand this one. Stay with me, stick with me. We're almost there, guys. All right, so compounds are pure substances, just like elements. They're both pure substances. They're both pure. But a compound is no longer an element because an element only has one type of atom, whereas a compound has 2 or more types of atoms or elements making it up. And they are chemically combined together. They're like holding hands super tight. It's a strong chemical bond going on between them. And here I have an example of a chemically combined compound. Let's see if anybody can figure it out. Think about it. I'm going to give you a hint. Count the C's. 6C. So C6. I think some of you are starting to get it. C6H12O6. C6H12O6. This is going to be a compound, a big, large compound, or a big, large molecule, and we're going to call this thing what? Glucose, yeah. We know all about glucose. We've been talking about glucose all year long. It's what plants produce during the process of what? Yep, plants produce glucose during the process of photosynthesis. They get their energy from the sun. Yep, using photosynthesis, they create a sugar called glucose, which is C6H12O6. So this is going to be a compound because it has 2 or more elements. And actually, this has got 3. It's got carbon, it's got hydrogen, and it's got oxygen. So it's got 3 elements making it up. Now here I have another example. This one's easy. Look, it's got 1 carbon and 2 oxygens. Think about it. 5, 4, 3, 2, 1, go. What is it going to be? That's going to be CO2. CO2. Notice right here, the C goes there, and these O's go there to make it CO2. That's also going to be a compound because it's got 2 elements chemically combined together. That's what the lines mean. The lines mean a chemical combination going on. Are you with me? All right, guys, let's wrap it on up now. Moving on into the last part. The last thing, this is just a vocabulary word because I don't want you to be fooled on the past test. I want to be smarter than everybody else in the county, guys. So, last thing, just to remember, compounds are sometimes also called molecules. When you get to college, you'll learn the difference. You don't need to know that for now. I just want you to be familiar that there is another kind of scientific word called molecule. And for the purpose of 7th grade, you're going to be a genius if you can remember that compound and molecule are pretty much the same thing. Are you with me? Compound, molecule, same thing. And you're going to hear me use them interchangeably because that's okay for our purposes. If you know these words, you're in good shape. One more time, what was this compound? Glucose, good. And where do we get glucose? We can't make it in the sun. We have to do what? We have to eat. We got to eat food. We got to eat food. It goes in our mouth, down our esophagus, into our stomach where the gastric acid starts to break up stuff. Then it goes into the small intestines. We absorb it, gets shipped through our circulatory system and dropped off at cells. So this is glucose. We turn this glucose into a fancy usable energy called ATP, all right? Last compound molecule that we talked about today was CO2, all right? CO2. Now, let's move on. Let's see what you can remember. Let's see what you know. Blank are composed of 2 or more elements that are chemically combined. 5, 2, 1. Good job. The answer is going to be compound. An atom is a pure, simple thing by itself. Atoms and elements kind of go hand in hand. They're pure and simple by themselves. But compound is when you have 2 or more, like glucose, carbon dioxide, water. 2 or more. What's another word for compound? Starts with an M. Molecule. Good job. Let's go. All right. Matter must have blank. You've heard me say this 1,000 times already. Ready, set, go. Good. Answer there is mass and volume. Matter must have mass and volume. Which of the following is not, when I take the past test, I'm circling that word that's going to stick out to you, not considered to be a molecule? So which one of these would not be a molecule? This is tricky. Because you know that molecules have 2 or more elements chemically combined. So CO2, that's going to be a molecule because it's got 2 different elements, carbon and oxygen. C6H12O6, that's going to be a molecule because it's got carbon, hydrogen, and oxygen. H2O, that's got a hydrogen and an oxygen, so that's going to be a molecule. So the only one I'm left with here is hydrogen. Now, even though it's two atoms bonded together, it's just going to, because it says H2, H2 likes to be together with somebody, it's going to be it's not really going to be a molecule because it's not got two different types of atoms, guys. That's a tricky question. Let's roll on. Which of the following is the chemical symbol for nitrogen? Maybe you don't know this. I just want to see what you know. Let's see what you can do. 5, 4, 3, 2, 1, go. Answer is D, nitrogen. D is going to be N for nitrogen. NT is not really an answer. It's a crap answer. It's not even on the periodic table. Ni is actually a chemical element. You can look that up for 5 bonus points and let me know what that's going to be. And Ag, you got to figure out how to get it to me too. The Ag is going to be another element. I'm going to let you look that one up, and I'm going to tell you that's a valuable one. So if you can find that one, email it to me or and moto me. This will get you 5 bonus points, these two, if you can figure out what they are, all right? But this is a really valuable one. But the answer here for nitrogen is going to be N, D. All right, we're moving on. Which subatomic particle is found whirling around the nucleus? So that means it is in the nucleus or it's not? That means it's not in the nucleus. It means it's not in the nucleus. So I remember that C, I remember that C is in the nucleus. Neutrons are neutral charged. D is a crap answer. That had to do with cells. That didn't have anything to do with chemistry. Electrons and protons. Which ones are going to be? 5, 4, 3, 2, 1. Best answer here is going to be B. Electrons are found in an electron cloud. Remember I said that word? Just somewhere outside of the nucleus. They're not in the middle. Moving on. The term blank is also used to describe compounds. 5, 4, 3, 2, 1. Best answer here is going to be molecules. We can use molecules and compounds interchangeably. Be ready for that. That's going to really make your map scores go up if you know a word like molecule. All right, guys, moving on. Elements can actually be reduced into simpler substances. 5, 4, 3, 2, and 1. It says right here in my notes on Roman numeral 2 that they cannot be. So the answer is going to be false. Elements cannot be reduced into anything more simple than that. That's all they are.
Say I've made up my mind, don't need to think it over. If I'm wrong, I am right. Don't need to look no further, this ain't last. I know this is love, but if I tell the world, I'll never say enough, 'cause it was not said to you, and that's exactly what I need to do if I end up with you. Should I give up, or should I just keep chasing pavements, even if it leads nowhere? Or would it be a waste, even if I knew my best? Should I leave it there? Should I give up, or should I just keep chasing pavements, even if it leads nowhere? I build myself up and fly around in circles, waiting as my heart drops and my back begins to tingle finally. Could this be it all? Should I give up, or should I just keep chasing pavements, even if it leads nowhere? Or would it be a waste, even if I knew my best? Should I leave it there? Should I give up, or should I just keep chasing pavements, even if it leads nowhere? Yeah. Should I give up, or should I just keep chasing pavements, even if it leads nowhere? Or would it be a waste, even if I knew my place? Should I leave it there? Should I give up, or should I just keep on chasing pavements? Should I just keep on chasing?
Some people live for the fortune. Some people live just for the fame. Some people live for the power, yeah. Some people live just to play the game. Some people think that the physical things define what's within, and I've been there before, but that life's a bore, so full of the superficial. And some people want it all, but I don't want nothing at all. If it ain't you, baby, if I ain't got it, you, baby. Some people want diamond rings, some just want everything, but everything means nothing if I ain't got you. Yeah. Some people search for a fountain. The promise is forever young. You know, some people need 3 dozen roses, and that's the only way to prove you love them. Hand me the world on a silver platter, and what good would it be? No one with me, baby. Ooh, said nothing in this whole wide world don't mean a thing if I ain't got you with me, baby.
I'm so in love with you. Whatever you want to do is all right with me. 'Cause you make me feel so brand new. And I want to spend my life with you. Let me say since, oh baby, since we've been together, ooh, loving you forever is what I need. Let me be the one you come running to. I'll never be untrue. Oh, baby, let's stay together, loving you weather times are good or bad, happy or sad. Ooh, yeah. Whether times are good or bad, happy or sad. Why somebody, why people break up, oh, and turn around and make up, I just can't see. You'd never do that to me, would you, baby? Being around you is all I see.